Hello friends, myself Rajendra Mahajan presenting my video on Laplace Transform of Periodic Function. In this video, first of all, I will discuss what is by periodic function. If f of t plus capital T is equals to f of t, once again I will repeat, if f of t plus capital T is equals to f of t, then that function is called as periodic function with period capital T. Then that f of t is called as a periodic function with period t. Means what? After every t, capital T, same cycle is repeated. Then it is also called as a periodic function. Examples of this periodic function: sine is a periodic function. Sine of t plus 2 pi is equals to sine t, known result to all of you. Therefore, sinusoidal waveform is a periodic function whose period is 2 pi. Similarly, cosine function is also periodic function. Cos of t plus 2 pi is equals to cos t. Sine and cos are the periodic function. These are the two known functions. After every capital T, same cycle is repeated. Then that after every period capital T, same cycle is repeated, suppose, then that function is said to be a periodic function. All waveforms, triangular wave, square wave, then half wave rectifier, full wave rectifier, all these are the examples of a periodic function. Therefore, I have written all these examples one by one. The first one, sine function, sine of t plus 2 pi as sine t. Instead of x, I have taken as t, or we can take any variable. Here I have taken t, sine t plus 2 pi as sine t. Similarly, cos of t plus 2 pi is equals to cos t. Therefore, that 2 pi is the period for sine and cosine. Then triangular waveform or triangular wave, square wave, half wave rectifier and full wave rectifier. All these are the examples of periodic function. Therefore, after knowing what is my periodic function, next step is we have to obtain the Laplace transform of that periodic function. And to obtain it, we take the help of the following result. Therefore, next point is the Laplace transform of periodic function. If f of t is a periodic function, then Laplace transform of that periodic function f of t is obtained by 1 upon 1 minus e raised to minus s capital T, integration from 0 to capital T of e raised to minus st small t into f of t and its integration with respect to t. By applying this formula, we can obtain the Laplace transform of that periodic function. Then some simple examples based on that formula. The first one, find Laplace transform of f of t when f of t is equals to e raised to t in the interval 0 less than t less than 2 pi. This is the given function, and along with this the another information is that f of t plus 2 pi is equals to f of t. F of t plus 2 pi is equals to f of t. This condition means that the given function is a periodic function, whether it is mentioned or not mentioned, but due to this condition it becomes a periodic function whose period is capital T and value of that capital T is 2 pi here. Therefore, as it is periodic function, we can obtain its Laplace transform by that previous result. Therefore, Laplace of f of t is equals to 1 upon 1 minus e raised to minus st capital f of t is the periodic function whose period is 2 pi. Then Laplace transform of that periodic function is obtained by that formula. Once again, I have written that formula. Laplace of f of t as 1 upon 1 minus e raised to minus s capital T, integration from 0 to capital T, and in bracket in that integral e raised to minus st t small f of t dt. Equation number 1. And then substituting the value of t as 2 pi. Therefore, Laplace of that function e raised to t as 1 upon 1 minus e raised to minus 2 pi s. Value of t is 2 pi. Integration from 0 to 2 pi e raised to minus st, and the function f of t is e raised to t. As base is same, we can add the power. Therefore, 1 upon 1 minus e raised to minus 2 pi s as it is, no change. Integration from 0 to 2 pi also as it is. And then combining power of e by taking minus common and t common. Therefore, minus of s minus 1 times t. And then integrating that term with respect to t by keeping all the terms as it is. Therefore, 1 upon 1 minus e raised to minus 2 pi s as it is, no change. Integration of this term is e raised to minus s minus 1 times t divided by minus of s minus 1 and limits from 0 to 2 pi. Substituting the upper and lower limit by changing it to cancel that minus sign. Therefore, 1 upon s minus 1 we take outside the bracket, and substituting the limit, upper limit as 0, e raised to 0 we get 1, and minus e raised to minus s minus 1 times 2 pi. In next step, you can substitute the value of e raised to 0 as 1, and this is the required Laplace transform of that periodic function. Then second example, if f of t is equals to two values, first one k for 0 less than or equals to t less than or equals to a, and second minus k for a less than or equals to t less than or equals to 2a, and the condition f of t plus 2a is equals to f of t. This condition means the given function is periodic function with capital T is equals to 2a. The period of that periodic function is 2a. Therefore, we write down once again given f of t as k 0 less than or equals to t less than or equals to a, and second value as minus k a to 2a, and the capital T as 2a as the period of that periodic function. Means after every 2a, same cycle is repeated if we try to draw the figure for this function. We are getting a square wave form. Then Laplace transform of this periodic function is obtained by the same formula whatever I have discussed in the last example. Therefore, Laplace of f of t as 1 upon 1 minus e raised to minus s capital T integration from 0 to capital T e raised to minus st into f of t, and then its integration with respect to t. Substituting the value of capital T as 2a, therefore it is 1 minus e raised to minus s times 2a. I have written it in green color, and integration from 0 to 2a e raised to minus st f of t dt. Function is having two values, therefore next step we have to split this integral as per the given function. Therefore 1 minus e raised to minus 2as, then splitting that integral as 0 to a and a to 2a. Between 0 to a the value is k, therefore it is e raised to minus st into k. Yes, first value is k and its integration with respect to t, and second value is minus k, therefore taking minus sign common we get middle sign as minus in next step, and limit from a to 2a. From these two terms we can take k common, therefore it is k divided by, it is a square minus b square, factors are a plus b and a minus b, therefore it is 1 minus e raised to minus as and 1 plus e raised to minus as. A square minus b square as a plus b and a minus b, and integration of the first term is e raised to minus once again I have written e raised to minus st dt, and second one is with minus sign e raised to minus st dt. The middle sign is minus instead of plus. Yes, and then integrating that two terms individually, other term as it is, no change, k upon 1 minus e raised to minus as, and second 1 plus e raised to minus as. Integration of the first term is e raised to minus st divided by minus s, limit from 0 to a, and minus in bracket, integration of that term is e raised to minus st by again minus s, limit from a to 2a. Then substituting the upper and lower limit for both the terms, other term as it is, no change, therefore k upon 1 minus e raised to minus as and 1 plus e raised to minus as, no change in bracket, minus sign cancel by changing the upper and lower limit, therefore for upper limit we get, yes I have taken common, e raised to 0 as 1 minus e raised to minus as, then minus minus it become plus e raised to minus 2as and minus e raised to minus as, outer bracket complete. Then other term as it is, no change, k upon that 2 bracket 1 minus e raised to minus as, and second 1 plus e raised to minus as, and yes as it is, no change. Then substituting the value of e raised to 0, e raised to 0 is 1. There are two terms of e raised to minus as with minus sign, therefore addition is minus 2 times e raised to minus as and plus e raised to minus 2as. It is a square minus 2ab plus b square type of term, nothing but a minus b whole square, therefore 1 minus e raised to minus as a bracket square. Other terms as it is, no change. S 1 minus e raised to minus as and 1 plus e raised to minus as. One term get cancelled with that 1 minus e raised to minus as. Therefore, the remaining terms are k multiplied by 1 minus e raised to minus as whole divided by s into 1 plus e raised to minus as a required Laplace transform of that periodic function, a bar of s, a required answer. Okay, therefore, here I have explained two examples in this part 1. In next video, I will discuss part 2 of this periodic function. Please like my video, share it, as well as hype the video, comment down, subscribe to my channel, and press the bell icon to receive the notification. Thank you. Thanks for watching.